Assalamualaikum and hi everyone. So on today's video we're going to discuss on one example on how we can determine the cutoff frequency of any of your filter. So this example asks us to design a RC low pass filter, and the requirement for the filter is given in these two information. Okay, the first information that is said that the measurement signal will be lower than 0.2 kilohertz or 200 hertz, and it will block 100% signal at 180 kilohertz. Okay, so how can we determine cutoff frequency? Okay, so we do know that we have a gain equation or a transfer function equation for the RC low pass filter, which is 1 over square root 1 plus f over fc square. So we're going to determine fc here. So we can use these two conditions to determine gain. Okay, let's try the first condition. Let's say we say, okay, at 200 hertz, the gain is equal to 1 because we consider that it will pass 100% signal. Okay, so therefore our equation will become 1 equal to 1 over square root 1 plus 200 over fc square. However, if you try to solve this equation, you will find that you cannot solve it. Okay, we cannot solve fc using this equation. Cannot be solved. Okay, so let's try second condition here, second one here, where we said that at 180 kilohertz it will block 100%, meaning again will become 0, equivalent to 1 over square root 1 plus 180 kilohertz over fc square. So again, if you see, we cannot solve it because we need to multiply with 0 or divide by 0, then we cannot solve using this condition also. So how can we solve for fc, since both of the information cannot give a solution for fc? Okay, so let's try another method. Okay, so this method is based on the knowledge of a response of a low pass filter. Okay, so we do know that for a low pass filter it will respond something like this. Okay, so basically it's something like this. Okay, where we said here, okay, this is at fc, this is fc will give us gain 0.707, then the gain here is 1, then the gain here is 0.1, and it eventually goes to 0 at here. Okay, here is 0. Okay, so the knowledge that we know that from fc to here it is 10 times. From here to here it also 10 times, and from here to here it also 10 times. So what does 10 times mean? 10 times mean 1 decade. Okay, so I hope you still remember the concept of decade in log graph. Okay, so if we draw a line, okay, so this is here, this is here, this is here, and this is here. So let's say we have okay, 0 here is 1.8, not 1.8, it is 180. Okay, it is 180 kilohertz. Okay, which is the gain is 0. Okay, then a decade lower than 180 is 18. So 18 kilohertz will give you 0.1. A decade lower than 180 is 1.8. You can see 180 divided by 10 will give you 18. 18 divided by 10 will give you 1.8, and 1.8 divided by 10 will give you 0.18. Okay, so at 1.8K it gives us 0.707, and at 0.18K give us 1. Okay, so based on this knowledge, we should be able to predict, okay, our FC will be at 0.18 kilohertz because it is 100 times lower than 180K, which will give us gain 0. 10 times lower will give us 0.1. Another 10 times lower will give 0.707, and another 10 will give us 1. Okay, so therefore our FC will be equivalent to 1.8 kilohertz, or equivalent to 1800 hertz. Okay, let's solve for number 2. Number 2 is to determine R and C. Okay, so we can determine using the cutoff frequency 2 pi RC. So let's say that R is 10 kilo ohm. Therefore C will become 1 over 2 pi multiplied with 10,000 multiplied with FC is 1800. Okay, if you calculate, then you get 8.84 nanofarad. Okay, 8.84 multiplied by 10 to the minus of 9 farad. Okay, so 8 nanofarad. But the question asks for C1, CF, R1, and RF. So if you want to answer that question, meaning you say that, okay, C1, CF, R1, and RF is not applicable for low pass filter, because in low pass filter we only have value of C and R. Okay. Okay, the last question is asked us to draw a simple RC low pass filter. So you need to be able to draw that. Okay, so low pass filter will have resistor, then have a capacitor, then ground. So this is R equivalent to 10 kilo ohm. We have V in here, and then we have V out. Then the capacitor is equivalent to 8.84 nanofarad. Okay, so that's all for example number 1.